Hello everyone, my name is Iker Pereda-Agirre. I am a second year PhD student at ASTI and I am working on closed-skin mark recapture. My current work is on using closed-skin mark recapture for northeastern Atlantic fish stocks for abundance estimation. So first of all, I would like to begin by explaining what a stock is and what a stock assessment is also. So stocks are management units for fisheries, which are normally defined by geographical boundaries. And the stock assessment is the research focused on those stocks to evaluate the status of them. And this is done ideally before starting exploitation, but usually because it has already begun before being possible to do an assessment, it is done for enhancing this exploitation management. One of the most important aspects of the stock assessment is knowing how big the stock is. This lets us track its trends and evaluate fishing exploitation levels. So for this purpose, we have two major ways. One of those is fishery-dependent methods, such as catch per unit effort. The other way are fishery-independent methods, such as acoustic surveys or daily egg production methods. Now, introducing CKMR, what is it? So, closed-skin mark recapture is an abundance estimation method, and it is based on a more or less simple principle. This principle says that the probability of finding relatives within a random sample is inversely proportional to the size of the population they belong to. And also, taking a sample size, the proportion of kin pairs found in that sample should be same as the proportion of total number of kin pairs in the total population. It is useful first because it is a fisheries independent method, so it does not suffer from fishery dependent typic biases. Second, because it is more cost effective and faster to get results than other typical independent methods. And also, unlike other fishery independent methods, it can deal with lethal sampling, so we can also use commercial catches apart from survey samples. The problem is that it cannot be applied to any species because it is dependent on biology features and population dynamics. Here it is a guide on how to know if a species is suitable for closed-skin mark recapture. But basically, we could say that we need a species which lives long enough and has low enough mortality so generations can overlap. Also, we need a species abundant enough so we can sample without big problems, but not so abundant that we would need a too big sample. And then also, depending on fecundity or adult availability, we can either work with both parent offspring pairs and half sibling pairs, or just with the latter. So what we did was, according to the previous image, was select some northern Atlantic species of commercial interest that would fill those requirements. And these are the 7 species we selected. All of them have also previous assessments, which, as we'll later see, it is very helpful. So to start working with these species, some things had to be taken into account. First, the number of samples needed for a good estimation, and if that number is realistic. So if we can sample that number of samples in a feasible time. Then we need some species data from previous assessments, such as abundance or numbers at age. That will help us to know how much approximately we will need to sample, as we will later see. And then we have to also know specific features from that species, like the ones we mentioned before in the image, such as longevity or fecundity. All this data was collected from ICES reports, and for more specific data, we looked for further bibliography. So, to start with the initial suitability test, we analyzed biological features collected from our bibliography and formed a traffic light table, which is still in progress, as you see, and shows in a more intuitive way the suitability of different biological traits of all the species, such as overlapping generations or age estimation accuracy. Colors represent not only the adequacy of those aspects for each of the cases, but also the availability of that data. After considering if the species are biologically suitable or not, we can approximate how hard would be to sample each species, logistically speaking, so that we can estimate if it is worth for each case. So we do it with a software tool developed in R, which takes previous assessment data and a sampling plan as an input. This tool is more of an indicator and not an exact predictor, but it is very useful to check if what we expect is a total nonsense or if it can be feasible. That assessment data we mentioned must include numbers at age, weight at age, and maturity at age data. That's why we said that previous assessment data is useful. And the sampling plan must include the expected number of samples that will be yearly collected and a given time span in years for those samples to be collected. So this outputs the expected number of kin pairs that would be found within a sample. And with that value, we can tweak the sampling plan until we get the result we want. So that way, we would get a rough estimation on how much we would need to sample in order to get enough useful samples. We performed all these tests for a sampling plan of 6 years, where we would get 70,000 samples in total. Those 70,000 samples would be split equally through those 6 years. And so, because the coefficient of variation of the resulting estimation would depend only on the kin pairs found, assuming all the rest of variables are the same, which won't be, but as we said, this is more of an indicator. It is not an exact predictor. So, taking into account that the coefficient of variation would depend only on kin pairs, we set a goal on 50 kin pairs, which would be around a 15% coefficient of variation, which is pretty acceptable. And that is represented by the red dashed line on the right chart. So here I show the first result corresponding to a sampling proportion of adults to juveniles of 3:1. Here, both charts show the same information, and the next two charts will show the same information each other also. But the right one is excluding one of the target stocks because its number of kin pairs found grows much faster and doesn't allow us to appreciate the growing of the rest of the stocks. I will not focus on these results. because as we see here, in the case where 3/4 of the samples are juveniles and just 1/4 are adults, the results are often much better. To see it clearer, I have collected the results here. So for southern anglerfish, we would need 10,000 samples. For southern hake, 47,000 samples, and so on. And so the bad news come from mackerel and anchovy, which would need more than 2 million samples, and horse mackerel, and both horse mackerel stocks and both sardine stocks, which would need around 1 million samples. Well, this translates into around 0.001% of the total catches reported last year for southern anglerfish, and also for southern hake, as you see. And this doesn't grow a lot for the rest of the cases. So it seems like it's not that much. Also, we didn't only look at that, but we wanted to compare these numbers to the ICES reports numbers on about sampling levels on the corresponding working group reports, and see if we would get enough samples for a CKMR approach, and in how much time we would get that. So by comparing it, we saw that the case for the first 5 species would be very viable by achieving it in less than 6 years. And the only doubtful case is the one for northern megrim, which in the last 3 years, samples numbers have been widely changing. So best case scenario, it would get 3 years to get the necessary samples only in surveys. And worst case scenario, we would need either more samples in those surveys, or just having access to some of the commercial catches. So as a conclusion, we would like to remark that all species were biologically compatible. None of them seem to be impossible, only biologically. However, logistics were unviable for some of them, as we saw with the case of the anchovy or the mackerel. Some species are not only feasible, and this is a point we would like to remark. They are not only feasible, but already enough samples of those species are collected right now just from surveys, without having to access to commercial catches. Other species need either focused sampling strategy or access to some commercial catches. But that way, they would be feasible too. And as a future work, we would like to select the most suitable and cost-effective species from this list, develop a CKMR model for that stock by finding alternatives to that particular species. And finally, we would like to develop a step-by-step guide for newcomers to close-skin mark recapture, so that anyone that would be interested in applying it to any stock or species would have to follow easier steps to get to an initial evaluation to see if it is feasible for that species of interest. So that's all. Thank you. And if you have any question, don't doubt to do it. Goodbye.